Hello and welcome back. The following problem states, consider the following reaction of nitrogen dioxide reacts with oxygen to produce dinitrogen pentoxide. At a particular time during the reaction, nitrogen dioxide is being consumed at the rate of 0.00130 molarity per second. At what rate is molecular oxygen being consumed, and at what rate is dinitrogen pentoxide being produced? So there's two parts to this problem. The very first thing that you want to do when you come across a problem like this is you always want to write out the rate expression, because we're going to be using this to solve both parts of this problem. So in part A, we're looking at what rate is molecular oxygen being consumed, and they give us the rate of consumption of nitrogen dioxide. So we're going to use this expression to relate the two to one another. So we have negative rate of consumption of oxygen is equal to the negative 1/4 rate of consumption of nitrogen dioxide. And in this problem, they give us the consumption rate of nitrogen dioxide. And so all we're going to do is plug in to this expression the value in which nitrogen dioxide is being consumed, which is 0.00130 molarity per second. Well, once we do that, we'll divide each side by -1 as well to get rid of that negative sign, and we'll have the rate of consumption of oxygen is going to be equal to negative 3.25 times 10 to the -4th molarity per second. And in part B, we're going to look at the rate of production of dinitrogen pentoxide. So in order to do this part, we're going to use this expression right here. The -1/2 rate of, the positive 1/2 rate of production of N2O5 is equal to the negative rate of consumption of oxygen. Well, we know the rate of consumption of oxygen, so we plug it in. Molarity per second. We have to multiply each side by 2 in order to get rid of the 1/2 over here. And we get this is equal to 6.50 times 10 to the 4th molarity per second. Remember, in order to approach this problem, the very first thing that you want to do is write out the rate for this reaction, and then you can use it to substitute in what you know and what you're looking for.